All right, this one is a little drip or two coming out, but for the most part, we've got out of there. That's what was in it. Quite a bit. Hello again, everyone. Starting a new restoration today. Philco, model 610, made in the mid-1930s, specifically 1936, if I've done my research correctly. Around 80,000 of these were sold by Philco. Popular radio known as a tombstone because of the shape. A lot of good things going for it. Number one, we've got all the knobs that are supposed to be on it. Original knobs. The dial looks pretty good. No cracks in the bezel or the glass. The dial's a little faded, but we'll get into that once we get everything taken apart and do some more investigating there. Cabinet's in pretty good shape. Ding's right here on the top edge. So we'll see what we can do with that. But the rest of the cabinet looks pretty good. Like an original finish, it can be brought back to life. So let's get this taken apart and we'll see what we have to work with. Knobs just pull off. Okay. Wasn't too bad. We got all the knobs off. Now we'll pull the chassis out. Have two screws here in the back, here and here. And I don't believe anyone at the Philco factory wrote that. It is a 610, but it's not a Philco, it's a Philco. So, all right, let's see if we can get this chassis out. Speaker is permanently wired in, so we had to detach it. Little defect right there. This chassis uses these rubber insulators or rubber pads between the chassis and the cabinet, and they still seem to be in pretty good shape. Chassis kind of floats on top of that. Part of the original label's still there. That dial, really dirty. I think these are available. I have to look, see if Radio Days has those in case we can't get this one looking better. It's pretty rough shape, pretty faded. There's the rest of that label that was missing inside the cabinet. Definitely want to hang on to that. Yeah, most of it still. Little piece missing there, but checking out these controls. This is the on-off volume. It is really stiff, gummed up. Needs a good lubing and cleaning, but it still clicks, so that's good. It's a band switch. Tone switch. It's working okay. And an old style plug. All right, let's tip the chassis up and look underneath. This does have the caps that are in these networks. One there, and there, there, and there, and there. Several of those. Well, I found the rest of that label. And there's the rest of it. Those are original Philco speaker screws. Let's do a power up on this and just see if we get any action at all. Specifically a dial light. That'd be a good sign to tell you that the transformer is okay. And we might even get some noise, who knows. Plugged into the Syncor power right, so we're safe. Something goes wrong, well, that'll trip out and won't do any more damage. So let's put on we'll go about 100 volts for now. And I think it's turned off. It is. So let's see if we can power this on and see what happens. Well, that's a good sign. We do have a dial light. And we're drawing 0.3 of an amp. Not a filter hum. So we are getting some noise out of it. We're not tuning anything. It's a good first time power up. Obviously we're going to need to change some filter caps. We got 3 right here, and all of those Bakelite assemblies. Lots of caps to change in those. So let's get started. There was an early and late version of this chassis. From what I can find out, this changes in models, which means a later version would have these changes that have been done to it. We've got a resistor, and this is R9, I think. Yes, R9, which is some light down here, right here. 20 ohm resistor, and they've eliminated it in these later revisions, but this chassis still has it, and it's this one right here, and it checks about 23 ohms, so that tells me this is the early chassis. So I know what I'm working with now. This is a schematic we're going to be using. Our first order of business will be to check the tubes. We'll start with the rectifier tube and just work our way around, check all 5 of the tubes. Here's my tube tester. This is the RCA Cardmatic. Uses a punch cards, and our rectifier is number 80, so there's a punch card for it. So let's get the tube over here and see how it tests. We will need a 4-pin adapter, and here's my adapters that I've made for this tester. And there's our 4-pin. Just plugs into the 8-pin socket. Okay, we put our card down, turn the tester on. There's a power light installed where I know that it's on. And the first thing we do once the tube lights up and you can see the filament in the tube. We've got a meter reading and we calibrate. Should be right in the center. And that tube's not the best. In fact, it says renew, so this tube's pretty weak. Should be at least in the up in the green slightly. Now we also need to test plates 1 and plate 2, P1 and P2. You do that right here. The normal is P1, that's in the center. And if we go to P2, check's about the same. A little stronger, but not much. Well, I don't think we'll be checking the detector tube, 6A7. Guess that's why they had a tube shield on this tube. It's not supposed to have one, so I guess that was holding that tube in there, even though it was broken. See if we can dig up a 6A7 for that. Well, that wasn't easy to get out. You see that metal enclosure, the tube sits down inside it. It was difficult to get all of that out, but we got what was left of it out of there. Next tube we can test is this 78. That's the one with the loose cap. It's still attached, so let's see what it looks like. 78 tube is bad. And there's why. You see where that wire goes through the tube. Next is a number 42, and that's a 6-pin. Plug it into our 6-pin adapter. And that tube is good. Calibrate. Okay, that's fine. So that tube is good. That's the output tube. We finally found one good tube anyway. Next we have a number 75. And I actually had to make a test card for this tube. And again, it's a 6-pin, so same adapter. It does have a top cap, so plug that in. Now, in the testing instructions, it says to replace this tube if it tests under 2. So we're okay. There's 2 right there. And we're testing a little over 3. Now that's on plate 1. Plate 2 is a little better, about 4. Now let's put test card number 2 in and see what it says. And we're good there. Well, we had 3 bad tubes. The 80 rectifier, it was weak. The 78 was the one that had the broken cap lead, what went through the glass, so it's lost its vacuum. And then the 6A7 that was broken. Here's another Philco parts chassis that I have. And luckily it had 3 tubes that checked good that we needed in the chassis we're working on, so we'll put them in and see what we get. And we're still not receiving any signal, but our B plus is where it needs to be now. We've got close to 300 volts. We're right at 300 volts there on the rectifier tube. And when you turn the volume up, that's all we get. Well, some improvements. What I've done here, you see the 3 electrolytics. Just have them clipped in on top of the old ones. Not the ideal way of doing it, because the old ones can be leaky and drag the circuit down, but just wanted to see if I could get some noise out of this thing before we get deep into it. And that's made an improvement. We don't have a lot going on, but we definitely have a station trying to come in. And even with these clipped over the top of the old ones, our DC voltages are pretty close to where they ought to be. Starting to remove these electrolytics, and I was able just to loosen the bracket on this one right here. There's no way of getting to that screw because the transformer is in the way, so just having to take the bracket completely loose from the chassis on both sides. That'll work too. And this one, it's isolated from ground, so I disconnect the leads underneath. I can pull it out. I need to clean this chassis while I've got them out of the way. See, I've already removed the rectifier tube, so I can get in here and do some cleaning. Because of those dog bone resistors that I'll probably have to replace a good percentage of, I'll just be using modern resistors. I'm not going to worry about restuffing these caps. I just cut the lug off, and I won't cut these apart and try to get the insides out. We'll just clean those up, put them back in just for appearance sake, and we'll mount electrolytics either on terminal strips, or have to look into it to see how I can efficiently mount them to where they won't be in the way. Let me do some cleaning on it, and then I'll show you what the finished product's going to look like. I think it's going to be a lot better. Here's what I come up with for these 2 caps. I've taken them out, been cleaning on that one. There's the other one. Both of these are just electrolytics that go to ground. One is an 8 microfarad, the other is a 12 microfarad. But we have both of them mounted on a terminal strip. Cap number 3 installed, and mounted this terminal strip on this screw coming out of this mount for this trimmer. And it is isolated ground, so we just use the 2 terminals on the ends. This is a minus. It's a minus right there, and the plus is right here. This first electrolytic I've been doing some cleaning on. It's completely dried out inside. You can hear the internal parts moving around, but there's no liquid coming out. Now this second one, I took the bracket off and just cut a little hole in there, and there's still some liquid left in it. We need to get all that old liquid out of there. There's some pouring out at the end. All right, this one, still a drip or two coming out, but for the most part, we've got out of there. There's what was in it. Do the same thing with this third one that's isolated from ground. It's got a little weight to it, so I'm sure there's some water still in it. And I think this one's had a little leak here at the top. Taking off these cardboard sleeves. Yep, she's been leaking out. Scraped off all we could of the old electrolyte there. This sleeve on the bottom, I just split it. It comes right off. We'll put all that back on, make it look original. Now I'm going to cut a hole in this one. Definitely got some liquid in it. They just used a piece of rubber to seal these caps at the ends. And rather than cut this thing all apart, just punch a little hole so it can get some air, and push that center terminal back in there, and I'll clean out all that rubber I can, and that should let it drain out. Oh yeah, quite a bit in that one. All right, I'm going to stand these up over in the corner, put them upright, just let them continue to drip. That way we'll make sure we get all the water out of there. I'm pretty sure this is going to get all the water out of those caps. But just to be sure, before I mount these back, I'm just going to seal these ends up with some caulk, with a squirt of silicone. That way they'll be sealed up and nothing will come out then. And here's where I've been cleaning. It's going to look a lot better. Just use some evapo-rust. We need to clean some more up in here as far as we can reach before we put those caps back. Here's my technique on cleaning this chassis. First I use the evapo-rust. That is a gel, so it's not too messy. It sticks on there pretty good. That's what you're seeing here. And then once it does its job, just go back with Q-tips and just wipe it off. It does a pretty good job of getting the chassis clean. Stamped on the chassis, it says T71999. So does that mean 71,999 if they made 80,000? Possibly. There's some rust up here we're going to try to get rid of. I've already put a couple of coats of evapo-rust. I may try one more time. There's all our tubes cleaned up. Ready to go back in once we get this chassis cleaned up a little better. One thing I might mention on cleaning these tubes, be really careful. Some of these numbers are just put on with ink and they'll come off really easy. Some are etched. You want to put a whole lot of pressure because you'll wipe that number off if you don't watch. That'll do it for part one of the Philco 610 Restore. Thanks for watching. We hope you've enjoyed the video. And if you did, how about giving us a like and subscribe to our channel? Thanks.